extend my sincere thanks to. First of all, I extend my sincere thanks to authorities, principal, faculty members of Patrick College, Chennai, for offering me this wonderful opportunity to act as a resource person for this 7-day FDP. With this, I don't know whether I deserve for this, but anyway, I shall try my level best to justify for this session. Straight away with this short intro, and straight away I'm going to my presentation. Ma'am, nowadays, you all know the main agenda of any higher education institution or college is research, teaching, research, publication, and consultancy. That too in NAC, research played a vital role, not only in NAC, but also in NIRF or other grading agencies like the and everything. Research plays a vital role, of which nowadays every higher education institution is expecting publication in Scopus Index journals. Today we are going to cover few statistical tools which you can employ not only for PhD guiding while you are guiding PhD scholars, but you can even think of make use of the following statistical tools while you move for publication in Scopus Index journals and other things. First thing I'm going to say about the simple frequency table. As I start with the simple, what is the purpose? That's the main thing. Everyone, almost I noted, almost all faculty are said to be or doctorate. When you writing, when we move for higher education and higher studies, we need not to mention the formula for computing various statistical tools. It is for UG level, it is acceptable. Or just to increase the page, we can mention the formula and other things. When we move for higher education, kindly avoid mentioning the formula or procedure for computing and analysis. Instead of, kindly mention the purpose of applying the statistical tool. First, as far as nominal data is concerned, nominal is nothing but when number is assigned for identification purpose, it is called as nominal scaling. Example, we can assign, we may collect data for gender. For male, we assign 1. And for female, we may assign number 2. Here, number is assigned not for differentiation between male and female. Here, number is assigned only for identification purpose. So, we can say, so it is called as nominal scaling. It's not nominal scaling is nothing but when number is assigned for identification purpose, it is called as nominal scaling. Example, in your college, we assign the register number for students. In here, registration number is assigned not for differentiation between advanced learner and slow learner. Here, register number is assigned only for identification purpose. When number is assigned for identification purpose, it is called as nominal scaling. Usually, when we construct a questionnaire, surely we will make use of 3 types of scales. One is nominal scaling, another is ordinal scaling, and another is Likert scaling, or what do you call as ordinal scaling. So, nominal, ordinal scaling, uniform. Okay. Then the ratio scaling is for secondary data. And when we make use of nominal scaling, for nominal scaling and data, you can make use of simple percentage. The purpose of simple percentage is to identify in which category majority of the respondents reside. I took an example of, for example, one denote male and 2 denote female. We have collected data from 300 respondents, of which it is inferred, it is noted 174 are male, belong to male, 174 are male, and 126 are female. From this, we can infer that majority of the respondents or majority of the customers belong to male category. Similarly, if you note down while we write interpretation, we can write like this. Out of 300 respondents, 174, within bracket, you can mention, if needed, you can mention the percentage, 58 are male, and the rest are, and the remaining 126, within bracket, you can mention the percentage 42 are female. when the percentage is more than 50, we can make use of the word majority. If the percentage is less than 50, we can make use of more. Instead of using the word majority, we can make use of the word most. So, for this example, we can say as the male percentage is more than 50, we can infer this majority of the respondents are belong to male category. Okay, this is about the simple percentage. If time permit, as due to time constraint, I'm not in a position to work out in SPSS. So instead of working out, already I have mentioned in PowerPoint. Next is reliability test. Before moving to any analysis, first we want to offer justification whether the collected data is fit for analysis. Okay, whether the collected data is fit for analysis, for which we want to measure the reliability test. By conducting reliability test, you can justify that your collected data is fit for carrying out statistical analysis. We all know the main problem of primary data is biasness. And that is none of the respondents may answer without reading the questionnaire, or they may offer some fake answers. Say example, if you raise the monthly income, no one is ready to disclose the real monthly income or family income, etc., or even the age. So they may see few persons may exaggerate, or few may something. So before carrying out analysis, it is advisable to employ reliability test. So you can, by making use of Cronbach alpha, we can say the data is reliable. If the once you computing Cronbach alpha, if the calculated Cronbach alpha is greater than 0.7 and above, we can say the data is said to be reliable. On few occasions, few authors mentioned that the calculated Cronbach alpha value is 0.5 and above is also said to be reliable. But the ideal rule is if the calculated Cronbach alpha value is 0.7 and above, we can boldly infer the data is said to be reliable. What is the statistical tool? This Cronbach alpha. It is available. I hope if you if the faculty make use of SPSS, you are aware that how to compute reliability test. So the statistical tool appropriate for measuring reliability test is Cronbach alpha. So before carrying out any analysis, the kindly make use of Likert scaling data. For measuring reliability data, Likerts may kindly make use of Likert scaling data. That is, if you we may construct questionnaire. We make either strongly agree 5-point, 3-point, or 7-point scale. So make use of the data for measuring the reliability. Instead of making use of nominal data or ordinal data, kindly make use of Likert scaling data for measuring reliability. Once the data on making use of reliability, Likert scaling, if you infer the Cronbach alpha values greater than 0.7 and above, we can boldly say the data is fit for analysis. Then you can proceed for further analysis. Ma'am, whether the voice is audible?
Yes, sir, it's audible, sir.
Okay, ma'am.
Yes, sir.
Next is the main thing, normality. And we noted in most of the Viva's examination, most of the scholars, knowingly or unknowingly, they are employing various tests like ANOVA, independent t-test, chi-square. The main thing is analysis of variance, that is ANOVA or independent t-test is a parametric test. Chi-square is a non-parametric test. When we evaluating a thesis, if any of the examiner noted, if a scholar has employed both analysis of ANOVA and chi-square, and as I mentioned, ANOVA is a parametric test, chi-square is a non-parametric test. The main question which we shoot is why you employed both parametric and non-parametric. Either whether the scholar has computed the analysis, or you make use of some, whether you make use of some outsourcing for computing analysis, kindly justify why you employed parametric and non-parametric test. Okay. Before identifying whether to employ parametric or non-parametric, we should measure the normality test. Okay. The purpose of employing normality test is to identify whether the population is normally distributed, whether our collected data to measure whether our collected data is normally distributed. You can employ normality test. For which there are two methods of computing normality. One is first from the Likert scaling data, you can compute skewness, and from the same Likert scaling data, you can compute kurtosis. If you divide this skewness value by the kurtosis value, if the result varies between plus 1.96 and minus 1.96, we can say the data is normally distributed. Once again, I repeat, from the collected Likert scaling data, compute skewness, also compute kurtosis. As you, the skewness value will be divided by the kurtosis value, and if the result ranges between plus 1.96 and minus 1.96, you can say your population is normally distributed. Or another test is KS test. It is called as Cone-Grove-Seymour test. Yes, the word is very complicated to pronounce. Shortly, it is called as KS test. By employing KS test, that is Cone-Grove-Seymour test, we can identify whether population is normally distributed or not normally distributed. Okay, when you compute KS test, you all know we want to measure the p-value. After computing KS test, kindly measure the p-value of KS test. If the p-value is greater than 0.05 and above, we can say the population is normally distributed. The only test where is reverse distributed. Kindly, after computing p-value, kindly note down the significance value, or otherwise called as probability value, or p-value, shortly called as p-value. If the p-value, if the p-value is 0.5, if it is the 0.5 and above, then we can say the population is normally distributed. If the p-value is less than 0.05, that is, if it ranges between 0.00, 0.1, 0.2, 0.3, and 0.4, then it is inferred the population is not normally distributed. Okay, so by making use of Likert scaling, you can measure normality either by employing skewness and kurtosis test. If you employ skewness and kurtosis test, the value, the range value, the answer value should range between plus 1.96 and minus 1.96. If the computed value ranges between these two extreme ends, we can say that population is normally distributed. Or if you make use of KS test, if the calculated p-value is greater than 0.05 and above, we can say the population is normally distributed. If the p-value is less than 0.05, then it is inferred the population is not normally distributed. Okay, if you look at this example, if you note down all the values of p-values as significant values, it is noted all values are less than 0.05. It implies the population is not normally distributed. That is, your data is not normally distributed. If your data is not normally distributed, you should employ only non-parametric test. If your data is normally distributed, you should employ only parametric test. So if the population is normally distributed, you should employ only parametric test. If your population is not normally distributed, then you should employ only non-parametric test. This is the evidence of showing why you employed parametric or non-parametric. So, as I already mentioned, most of the scholars are making use of, when we go through their thesis, we have noted they have employed ANOVA independent t-test. ANOVA independent t-test is a parametric test. Later on, they also employed chi-square. Chi-square is a non-parametric test. Okay, if we raise a question, why you employed both parametric and non-parametric, there is no answer. So, my dear friends, kindly note down, if the population is normally distributed, you should employ only parametric. When the population is not normally distributed, where only you should employ only non-parametric test. Ma'am, whether there is any doubt till this moment? Or shall we proceed? Or if there is any doubt, I will clarify and will look into other slides.
Participants, if you have any doubts, you can raise your hands. Or you can type in Q&A.
Okay, shall we proceed, ma'am?
Sir, there is a question in Q&A. Can
Yes,
we
ma'am.
combine both tests?
We can employ, ma'am, but I will offer justification. For example, if we employ ANOVA and for example, if you make use of ANOVA and chi-square, we want to offer justification like that, ma'am. For example, for a set of Likert scaling question where population is normally distributed, where we employed parametric test like ANOVA independent t-test, where another set of data which is found not normally distributed, for which we employed non-parametric test. For example, madam, if you have raised two set of questions, one is you are measuring service quality, and another set you raise a set of question for measuring customer satisfaction. Example, you employed ANOVA and independent t-test for service quality, and you employed for customer satisfaction if you employed chi-square, knowingly or unknowingly. For you can when any query raises why you employed both parametric and non-parametric, you can explain or you can offer justification. Sir, for a data set, so for a service quality, it is noted the service quality data set is as the service quality data set is normally distributed, we employed parametric test. Yes, customer satisfaction data set is found not normally distributed, hence we employed chi-square test. So in such a way, we can, if you offer justification, examiners will accept. Okay, ma'am. You want to say for service quality data set, as the population is normally distributed, we employed parametric test. As customer satisfaction data set is found not normally distributed, I employed chi-square. Okay, ma'am. Any other questions, ma'am?
One more question. Based upon the nature of data, only we will fix the tools, right, sir?
Yes, ma'am. Based on the nature of, or if you raise questions like ordinal scaling, we should employ only ranking techniques like Garrett ranking or weighted average ranking. Okay, based on the scaling and based on the nature, we will fix the tools, ma'am. Any other question, ma'am?
No, sir, that's all.
Okay, ma'am. Thank you, ma'am. Next is, let me assume that our population is normally distributed. Okay, then we will employ independent t-test ANOVA. The purpose of applying independent t-test is to find whether mean means average. The mean differs between two groups. To measure whether average values differs between two groups, we can employ independent t-test if your population is normally distributed. Okay. For example, in a class, we have male and female students. To ascertain the average mark secured by all female students and the average mark secured by all female students differs, we can employ independent sample t-test. The purpose of applying independent is to find whether mean differs between two groups. Mean is nothing but arithmetic mean. In mathematics, we call as average. To ascertain whether average values differs between two category or two groups, we can employ independent t-test subject to condition if our population is normally distributed. Suppose let you assume if population is not normally distributed, the equivalent test for equivalent non-parametric test is Mann-Whitney U test. The same purpose. Independent t-test and man-Whitney u-test are, the purpose is one and the same, to find whether mean differs between two groups. Okay. If the population is normally distributed, you should employ independent t-test or z-test. If your data proves that your population is not normally distributed, instead of employing independent t-test, kindly employ man-Whitney u-test. Okay, ma'am, any doubts in this regard? Now I will employ, say, what is the to measure mean difference between two groups. What test to be, if the population is normally distributed, I will suggest a parametric as well as non-parametric. As I mentioned, if to measure whether mean differs between two groups, if population is normally distributed, employ independent t-test. If population is not normally distributed, instead of employing independent t-test, kindly employ man-Whitney u-test. Okay. Shall we proceed, ma'am?
Sir,
Next
yes,
is
sir.
next test is ANOVA, to measure whether mean differs more than two groups. If we want to measure whether the mean differs between two groups, you should employ independent t-test or man-Whitney u-test. If we want to measure whether mean differs more than two groups, the more than two groups implies the group may comprise of 2, 3, 4, or 5. For example, if we want to measure whether the knowledge differs based on the area of residence, like urban, semi-urban, rural. In this example, we divide the entire population into more than two groups, namely as urban, semi-urban, rural. So, to measure whether mean differs more than two groups, we can employ an analysis of variance. Or you can even classify the education as 10th standard, 12th standard, diploma, UG, postgraduate, professional. Here we have classified the groups into more than two groups. So if we want to measure whether the mean differs more than two groups, kindly employ analysis of variance. When we can employ analysis of variances, if your population is normally distributed. As analysis of variance is a parametric test, when your population is normally distributed, and if you wish to measure whether if you wish to measure the mean differs more than two groups, kindly employ analysis of variance. The equivalent non-parametric test is Kruskal-Wallis H test. The purpose is one and the same, and the purpose of computing analysis of variance and Kruskal-Wallis H test are one and the same. The purpose is to measure whether mean differs more than two groups. More than two groups. It may be 3, 4, or 5. It is up to the discussion as you have framed in a questionnaire. Okay. So if you want to measure the mean difference between two groups, you can employ either independent t-test or man-Whitney u-test. If you want to measure whether mean differs more than two groups, you can employ analysis of variance, or equivalent non-parametric test is Kruskal-Wallis H test. Next, we are going to look into paired t-test. The purpose of applying paired t-test is to find the before and after effect. To find before and after effect, we can employ paired t-test. Example, we can look into A is a concern, is a profit-making concern. A is a profit-making business unit. It takes over the loss-making unit of B. It takes over the loss-making unit of B. And we are looking into, after taking over the loss-making unit, what is the earning potential of A? So we are going to measure whether the earning potential of A differs before taking over of the company or after taking over the company, whether the earning potential differs. This is we call as before and after effect. Or we can make use of our women empowerment. In most of the what we call a self-help group or women empowerment, we can identify whether the earning potential of female members has or have improved before joining self-help group, after joining the self-help group. we will compare the earning potential or their social empowerment or political empowerment or financial empowerment. What is the earning potential? If you are measuring the financial empowerment, we will look into what is their earning potential before joining self-help group. What is their earning potential after joining the self-help group? This is the I call as before and after effect, to ascertain whether there is any change in their financial condition or financial position after joining the self-help group. We want to compare the before, what is their financial potential before joining the self-help group or after joining the self-help group. Then to measure the difference, we can apply parity test. Okay, so here the parity test is employed to measure before and after effect. Before and after effect. So to measure whether there is an improvement, or for example, we can usually for slow learners or when a student fail, we will arrange a special class. Then we can measure the earning and the marks secured by the student before attending this special class, after attending this special class, whether there is an improvement, for which we can employ parity test. Parity test is a parametric test. The equivalent non-parametric test is Wilcoxon test. The procedure for computing both the tests are one and the same. The only thing is, if population is normally distributed, we will employ parity test. If the population is not normally distributed, instead of employing parity test, we want to employ Wilcoxon test. Next is chi-square. Chi-square is a parametric test. There is no alternative parametric test. Chi-square is a non-parametric test. There is no equivalent parametric test. So, when the population is not normally distributed, you should, and then too, and if you want to measure the association between variables, the ANOVA is employed and to measure whether mean differs. The purpose of employing ANOVA is to measure whether mean differs between more than two groups. If we want to measure the whether the mean differs between two groups, you will employ independent t-test or something. But if you need to measure as per your objective, if you want to measure whether there is any association between two variables, kindly employ chi-square. That too, when you can employ if your population is not normally distributed. If your population is normally distributed, you are not in a position to employ chi-square because there is no parametric test. Okay, so based on your objective, if you are interested, if you based on the objective, if you want to measure association and that too your population is not normally distributed, then only you should employ chi-square. The purpose of chi-square is to measure to find association between two variables. And I could quote an example. For example, we can say the knowledge level or IQ level. We can compare our IQ level or knowledge level with our education qualification. Then we can say IQ level is associated with education qualification, or knowledge is associated with education qualification. In such a way, we are associating between two variables. Or you can even infer sales and profit are associated. That is, the main is the word, the associated. If you want to measure whether there is any association between dependent and independent variable, or to find whether there is any association between two variables, we can employ chi-square. This is the purpose of employing chi-square. Then the main thing, if your population is normally distributed, then only you should employ chi-square test. Any doubts, ma'am? Any queries?
Any queries? Any questions from participants? You can also raise your hand. No, sir. No
Okay, ma'am. Okay, ma'am. Next is correlation. The purpose of correlation is to measure nature of relation between two variables, between dependent, not two variables, between dependent and independent variables. To find nature of relation between dependent and independent variable, we can employ correlation. If your population is normally distributed, you can employ Pearson correlation. If your population is not normally distributed, instead of employing Pearson, kindly click Kendall's coefficient. Okay.
Sir, good evening, sir. Sir, good evening.
Good evening, ma'am.
Sir, as you said that chi-square is about finding what is the relation between variables. So
Yes,
in that case, is it about the significance of the factors and the variables that we are testing, or it
Yes.
is just between the variables we see what is the relation between each other, and how does it affect?
We are testing the significance, ma'am. Whether we are identifying whether there exists any association between the selected two independent variables, and we are identifying whether the selected variables are said to be significant or not significant. Okay, based on the p-value, if the p-value is less than 0.05, we can say there is a significant association between two variables. If the calculated p-value is greater than 0.05 and above, we say we infer there is no association between two variables. Okay, ma'am?
Yes, sir. Yes, sir.
Okay. Next is correlation. The purpose of employing correlation is to measure whether the nature of relation exists between two variables, between dependent and independent variables. To measure nature of relation exists between dependent and independent variables. Here the nature of relation mentions whether there exists positive relation or negative relation, or there is called as positive correlation or negative correlation. For I say an example, we can compare profit and sales. Here profit is said to be dependent variable and sales is said to be independent variable. When sales increases, automatically profit also increases. We can say there exists a positive correlation. One more time I will repeat. We are comparing profit and sales. Here profit depends on sales. So profit is said to be dependent variable. Sales is said to be independent variable. When sales increases, automatically profit also increases. We can say there exists positive correlation between sales and profit. Implies whenever there is an increase in sales, there will be increase in profit also. And that negative example, for example, we can compare expenses and profit. Here also the profit depends on expenses. When here profit is dependent variable, expenses said to be independent variable. Whenever we reduce the expenses, automatically our profit will increase. So here expenses is the independent variable. That is when the value of independent variable decreases, and then the value of dependent variable increase. It is an example of negative correlation. Okay. When the same thing, when your population is normally distributed, you can employ Pearson. When your population is not normally distributed, instead of employing Pearson, you can employ Kendall's correlation. The same menu, it is available. Instead of you are going to click, instead of clicking Pearson, you want to click Kendall's correlation. Okay, this is the purpose of employing correlation. Okay, next is regression. Regression, there is no parametric and non-parametric. It is only one thing. The purpose of regression is to find combined influence of select independent variable over dependent variable. While writing purpose of tools, instead of writing in mathematics terminology, in mathematics or statistics, we will say by making use of regression, we will predict the future values or some other to predict the values of X or Y. It will create confusion. Always try to make use of very simple terms in social science terminology, so that all readers can easily understand the purpose of applying each and every tool. So you can simply say that, like that, for example, to find the combined influence of select independent variables over dependent variable, regression test is simple. I will quote an example. For example, assume there's a participant yourself as a salesman, you are a produce manufacturer. The main goal of the manufacturer is profit. How the profit can be increased by increasing sales. Let me assume now your ambition is to increase the sales. Your ambition is to increase the sales. For example, you are running a firm. No initiative have been taken by yourself. If it is so, the average sales stood at, for example, 100 rupees. No initiative have been taken by yourself. If it is so, your average sales stood at rupees 100. Then you plan to increase the sales, for which you carried out advertisement. After carrying out your advertisement, your sales value switch over from 100 rupees to 140 rupees. Without initiating any step, your average sales stood at 100. When you started advertising about your firm or organization or a product, your sales increased to 140. That is, it switch over from shifted from 100 to 140. Here, this 40%, say the 40 rupees increase in sales is due to advertisement. Next, you are doing one more step. You are advertising your product. At the same time, you are also offering discount. Once again, I repeat. Initially, you have done nothing. Next step you initiate is you just advertise. You advertise your product alone, where your sales increase from 100 to 140. Second step is you carry out advertisement as well as you offer discount. You have introduced two steps. Then your sales increase to 160. That is by carrying out advertisement as well as by offering discount, your sales increase from 100 rupees to 60 rupees. Here 60 rupees is due to advertisement as well as the offering discount. Third method is offers. Buy one, get one. You are carrying out advertisement. You are also offering discount. You are also offering offers. Your sales increase to 180 rupees. That is by adopting advertisement, by carrying out advertisement, by offering discount, and also by offering offers, your sales increased from 100 rupees to 180. Your improvement in this is why called as combined effect. Okay. Initially, here the advertisement is said to be independent variable. Discount is said to be independent variable. Offers is said to be independent variable, whereas sales is said to be dependent variable, which is we mentioned as that is purpose of computing regression. That is to find the combined influence of select independent variables over dependent variable. In our example, we adopted advertisement. If we adopt advertisement, our sales rise from 100 to 140. If we make use of advertisement as well as discount, our sales increased by 60 rupees. That is called as combined influence. Finally, if we make use of advertisement, discount, and offer, our sales move from 100 to 80. This is called as combined effect of 180 rupees is a combined effect of advertisement, discount, and offer. This is the purpose of computing regression. There are confusions. If you are sound in review of literature, you can select appropriate independent variables. But few scholars are not in a position to choose appropriate independent variables, where you can run a factor analysis, and if you whatever the significant variables which you found in factor analysis can be introduced as an independent variable in regression. Okay, if you look into the R-square value, if you choose the right independent variables, and the data the answers offered by the participants is genuine, the R-square value will always be high. Usually for secondary data, if you note down the R-square value, it may stood at 1.000. It is 100% the variables which is selected is appropriate. R-square is nothing, man. Whatever the independent variable which is selected, the contribution of all independent variables is mentioned in R-square. If you note down in our example, I think it is stood at 0.904. It implies the selected independent variables contributes dependent variable by 90.40%. So if you are strong in a review of literature, you can select appropriate independent variables or variables. Thereby, your R-square value will be high. Whenever the R square value is low, it is only due to two options. One is the independent variable which you selected is inappropriate, or data is not reliable. That is the main thing. In reliable, if you compute Cronbach, it may show reliable, but as far as R square, you can cook up the Cronbach value, but in regression, your reliability of data will be disclosed in R square value. Next is factor analysis. In mathematical terminology, we say to find multicollinearity among variables. Multicollinearity is nothing but, for example, if now we around, for example, if we 50, there are 50 students in our class. We are raising a question. We are expecting each and every student should have different answers. If 3 or 4 students offer the same answer, it is called as multicollinearity. If when there exists, when there is a multicollinearity, it is nothing but the same answer is offered. For example, variable 1 is offering the same answer. Variable 3 is also offering same answer, means there exists multicollinearity between variable 1 and 3. If it is so, we want to retain only one variable. We are not in a position to retain both the variables. If the when we retain more number of multicollinearity, where also the R square value in regression will be affected. This is the purpose. But in social terminology, we can say to find the most prominent or significant variables among the list of variables, we can apply factor analysis. For example, for measuring customer satisfaction or job satisfaction, you can construct 25 questions or 35 questions, Likert scale questions. Out of 30 questions, we want to identify whether all the 30 questions are significant or important, or out of 30, very few questions are said to be important, for which you can employ factor analysis. Okay. In social science, we can say that to find the important factors, or for if you want to measure the job satisfaction, we can write like this: to measure the prominent factors influencing job satisfaction, factor analysis employed. For measuring job satisfaction, you may raise 40 questions or 30 questions or 25 questions. It is up to your discretion. Out of 25 questions, whether we are measuring by employing factor analysis, we are measuring whether all 25 questions are important for measuring job satisfaction, or out of 25 questions, how many questions or how many statements are said to be important for measuring job satisfaction, for which we are employing factor analysis. Before employing factor analysis, we want to measure whether the collected data is fit for employing factor analysis, for which you want to employ KMO Bartlett test. Everything is available in the factor analysis. If the KMO Bartlett test value is greater than, as I mentioned, reliability, if the KMO Bartlett test value is greater than 0.7 and above, we can boldly say the data is fit for employing factor analysis. And next is in total variance. In factor analysis, it will show various analysis points, KMO Bartlett, and the another is main thing is total variance explained. If you note down this value student, out of, for example, out of, I think here we have raised 25 questions. 25 questions are converted into 8 factors. Okay. Very few are said to be insignificant, or few variables are not found to be significant. And if you note down this value, this cumulative percentage, it is 58.949, which says out of 25 questions or 30 questions, few questions are said to be significant. It may be around 20 questions or 15 questions. All these 15 questions contribute job satisfaction to a tune of 58.949%. This which denotes the points or questions which are found to be significant or alone contribute to a tune of 58.949%. And if you note down the rotated component matrix, okay, the values which are 0.5 and above are said to be significant. Few persons may consider 0.7 and above. Few scholars are considering 0.5 and above are said to be significant. If you note down, the 8 factors have been constructed. From based on the significant factors in each and every factor, you want to assign a common unique name. Assigning a unique name is said to be very difficult aspect of this factor analysis. Okay. Next, finally, I have not prepared no PowerPoint, but I wish to say about structural equation model. Now, most of the guides or research scholars making use of or employing structural equation model. And now, if you want to wish to publish in Q1 journals of Scopus, you can employ, if you employ structural equation model with mediating and moderating effect, surely your article will get published. But at the same time, you should have publications. You should, in review of literature, minimum reference in introduction paragraph itself, we want to quote minimum 25 to 30 references. Altogether, your references should be more than 100 and something. Your article can be published in Q1 if you employ properly structured equation model with mediating and moderating effect. Now, where to employ mediating and moderating or structured equation model? Based on your review of literature, you constructed a theoretical model. For proving your constructed theoretical model, you can employ either regression. Regression is also a powerful tool, is a multivariate analysis. Nowadays, we are, instead of employing regression, now we are employing structured equation model. Okay. So, to prove your theoretical conceptual model, we can employ either multiple regression or structural equation model. Structural equation model. So, before employing a structural equation model, you can think of confirmatory factor analysis. Where to employ confirmatory factor analysis? When you constructed a questionnaire, for example, in questionnaire you have 3 aspects. One is service quality, customer satisfaction, and loyalty. To measure whether relevant questions are raised for measuring service quality and questions are sufficient. To measure whether you raised the relevant questions and questions are sufficient for measuring service quality, customer satisfaction, loyalty, you can employ confirmatory factor analysis. Okay. Next is the main thing, structural equation model. The main purpose of employing structural equation model is to prove the conceptual model which we develop is appropriate. Where previously we simply employ structural equation model without thinking of mediating or moderating effect. Now, everyone making use of mediating and moderating effect. What is mediating variable? Mediating variable is nothing but how one variable affects. Mediating variable explains how one variable affects another variable. A mediating variable acts as an intermediary variable affecting 2 variables. Like we quote an example. If we want to measure service quality, customer satisfaction, and customer loyalty, better service quality leads to customer satisfaction. Once customers satisfied, they will become loyal. Here, customer satisfaction should be introduced as a mediating variable. It acts as an intermediary between what we call as service quality and customer loyalty. Because service, once the company or bank, if they offer better service quality, that leads to customer satisfaction. The satisfied customer will become loyal. So here we have the customer satisfaction introduced as a mediating variable. Whereas moderating is nothing but intensity of a contribution. Moderating variable mentions the intensity or extent of contribution. For example, digitalization. If we want to study digitalization, for example, or we can say we are here measuring digital marketing and purchase intention. digital marketing, and purchase intention. Here, usage. Digital usage depends on the age of a customer. Youngsters will make use of digital media than older persons. As I mentioned, the youngsters make use of digital media more than the elder persons, where here the age should be introduced as a moderating variable. It denotes youngsters who make use of digital media more have high level of purchase intention, whereas elders who make use of digital media low utilization will have low level of purchase intention. This is the way of introducing mediating and moderating. Mediating acts as an intermediary. Moderating variable influences intensity of contribution. Okay. With this, I conclude my session. Due to time, and if next permits, I will some other time we will think of showing the entire analysis in SPSS. That will based on the time future. With this, I conclude my session. These are the basic tools. We have discussed only the basic tools. I never say we have discussed all the tools. Okay. If you make use of some multiple multivariate analysis, you can think of publishing a quality article in reputed Scopus journals or book chapters indexed in Scopus. Okay. As I mentioned, nowadays, most of the scholars, most of the publishers are expecting high-end multivariate analysis. And the main thing, you can even employ regression. The only thing is they are accepting articles not based on the tools, how you are presenting. You should be genuine references. That too, kindly, while you publish, try to make use of past 5-year articles. Don't stick on with very old articles. They are not accepting. Suppose if you want to publish article in Q1 journals, always try to quote references from Q1 journals. If you make use of peer review journals, they will not accept. For example, if you want to publish in Finance India, try to make use of references that are published in Finance India or equivalent to equal level of journals. A Q1, if you want to publish in Q1, always try to quote references from Q1 journals. Or better, you can quote the references of the same journal. Suppose if you want to publish in Journal of Finance, try to quote the articles that are published in Journal of Finance because it will increase their citation and impact factor. Okay. With this, I conclude my session. Once again, I thank the organizers for offering this wonderful opportunity. If there is any question, I am now ready to clarify. Thank you.
Any questions from participants? Please raise your hand. Ma'am, please. Patamal ma'am.
Yes, sir. Sir?
Please, ma'am.
Sir, as you said, like the normality test decides whether we go for parametric testing tools or non-parametric testing tools. So
Yes, ma'am.
what is this normality test all about? Because say, I have actually collected 400 samples for my.
Okay. I will inform. I will quote an example, ma'am. For example, ma'am, if you draw a diagram, we will share if your diagram results like a bell shape, it is called as normality. I will quote an example. Ma'am, in India, out of 145 crores population, all are not said to be big shot, all are not said to be poor. Let me assume 5% of the population are said to be very big shots, very rich. And 5% of the population is said to be very poor category or below poverty line. If you make a diagram, it will resemble like that a bell shape. Okay. Now, out of 400 respondents and 500 respondents, few may answers, ma'am.
Yes, sir.
Everyone will not offer the same answer. Okay.
Yes, sir. Yes.
Only 5% category of populations in both in as well as positive and negative side will offer a differential answer or just like they cook the answer. Rest of the population will offer an average answer. That is
Okay.
the that is we are measuring in normality test.
Okay, sir. Okay.
Okay.
So we are taking the extreme out of the data and
Yes,
finding the
ma'am. Yes, ma'am. Yes,
normal
ma'am.
behavior.
Yes,
Okay,
ma'am.
sir. Thank you.
Yes, Meera ma'am.
Yes, ma'am. On behalf of Department of Accounting and Finance, shift to Patrician College of Arts and Science, I thank you sincerely for your valuable session on statistical techniques for data analysis. Thank you, sir, for your time and expertise. I also thank